All right. So the first section here is relations and functions. So I guess I'll preface that with saying, so final version of the final exam is going to be, I think, 32 multiple choice, 8 numerical response, and 7-ish written. Okay. Because we didn't get to spend a whole lot of time on measurement, I think there is maybe a total of 3 questions on measurement. Okay. Maybe 1 or 2 on unit conversions, and then 1 on surface area or volume. I can't remember. But so make sure you know how to look at the surface area and volume of a cone. Okay, good hint for you because you took the time to come here. Okay, all right. So that's that. Yeah, all right. So let's start looking at relations and functions. So first thing we looked at is technically I could be given any of these. I could be given an equation, I could be given the words, ordered pairs, arrow diagram, table, or even a graph, and I need to be able to convert back and forth between these forms. Kind of depends on what they give you, where you can start. So if we look at this, they gave us the equation, which means we're going to take that equation y equals 2x and change it into all of these other forms. So if I'm going to take this equation y equals 2x and put that into words, what would you say? Or how could you express that in word form? Yeah, exactly. So 2 times a number equals another number. And we kind of looked at creating equations from words and words to equations a little bit more in the system of equations unit. So I'm hoping that everybody's can be pretty fluid with taking that information and kind of converting back and forth between the two forms. The next one is a table. Well, sometimes it's a little bit harder to take a table and make an equation. Sometimes trial and error is the best way to do that. Or like look for a pattern. You can also look for a constant and multiplier to create your equation. So if I'm going to create a table here, I can just choose whatever numbers I want in the table. So let's say -1, 0, 1, and 2. If those are my x values, I take those x values and I put them in for the y value. So this would just be, take those x values, put them into here to solve for my y value. So this would just be like 2 times -1. Well, the corresponding y value is -2. 2 times 0 is going to be 0. 2 times 1 is 2, and 2 times 2 is 4. If you have a table, you can take all of that information and convert it into ordered pairs. And ordered pairs are just the coordinates that go on our graph. And remember, ordered pairs or coordinates on our graph are always in the form x comma y, right? Kind of alphabetical. X tells us how far it goes horizontally, and y is how far it goes up or down. So I can take those points and then pretty much just directly translate them into ordered pairs. So if I was to plot this line, there would be a point at -1, 2, right? -1, 2, x, y. And I could just do that with all of them. So there's a point at 0, 0. There's a point at 1, 2, and there's a point at 2, 4. All of those points for me. Arrow diagram, less of a fan of, but you still might see it, so I'll go through it. Arrow diagram is like kind of another way of just saying, here's x, here's y. It's a little bit more useful with functions. So if this is all of the numbers for x, here's all of the numbers for y. And so I just take the numbers in x and put them into that circle. So -1, 0, 1, and 2. All of the numbers for y go in the other set. So 2, 0, 2, 4. And the arrows just point from the x value that corresponds to the y value. So this one is just going to be pointing straight across because there's a point at -1, 2, 0, 0, 1, 2, and 2, 4. Arrow diagrams are a little bit more useful if we're determining whether or not something is a function. And we can talk about that when we go look at functions below. The last thing to do here, and that graph's really tiny, but hopefully I'll make it work, is being able to take an equation and graph it. Well, this one should be pretty easy, right? It's already in y equals, and we'll talk more about like graphing after, but this is the form you can also put in on your calculator. So I should be able to put it on my calculator and compare it to the graph that I'm given. Or if I remember like how to take an equation and graph it myself, so we'll get to this in a bit, but y equals 2x. If it's in this form, y equals mx plus b, so if it's in slope-intercept form, they're giving us 2 pieces of information. They're giving us the slope, and they're giving us the y-intercept. What's the y-intercept here? 0, 0, right? I can look and find the y-intercept a whole bunch, right? Because x is 0 here, x is 0 here, x is 0 here. So all of those tell me my y-intercept is 0. In addition, there's nothing here that's not there. So I know that I have a y-intercept at 0. My slope, which we'll again go through in a little bit more detail, my slope here is 2, so that's really 2 over 1. So to go to the next point, I'm going to go 2 up and 1 to the right. Or what I could have just done is take all of these points and plot them. So I have a point at 0, 0. I have a point at 1, 2. Ooh, this is a really small graph. I have a point at 2, 4. And as long as I have about 3 points, I should be able to, 2 or 3 points should be more than enough to sketch your graph out. Probably one of the easiest things that we look at that unit. Generally, given points or given a table and trying to create an equation is a little bit more difficult. The thing to remember is if you were given any of these pieces of information and they're like, well, what equation matches up, you can always just trial and error. Substitute numbers in, see which ones give you the exact same value. Okay. All right, functions versus not functions. So there's kind of like a few different circumstances we looked at and said, are these things functions or are they? Doesn't want me to. All right, functions versus not a function. Does anybody remember, like, definition-wise, how we can define these? What classifies a function? What classifies not a function? So a function will always pass the vertical line test. So pass the vertical line test. That's looking at a graph. Therefore, not a function is going to fail the vertical line test. So let's just maybe run with that, and then we'll kind of look at the definition. So passing the vertical line test means like take a vertical line, like my pen or my pencil, and then I just move it this way. And if at any point that vertical line gets touched by the line of the graph more than once, it fails the test, and it's not a function. So if I go and I bring this line or I bring my pen all the way through this graph right here, is it going to pass or fail the vertical line test? Fails. So this is a function or not a function? Not a function. Okay, then we'll go to the next one. Pass or fail the vertical line test? Passes it. So that's good. That's a function. The next one, this shape, pass or fail? Passes it. What about this one? It's going to pass as well. And the last one, passes or fails it? It's going to fail it right around there, right? So that fails. Okay. So vertical line test is always a great way to tell whether or not something's a function. Which means that anytime you're given information, so if you're given information just like this, like data points, and you forget the actual rule for a function, but you remember, oh, it's a vertical line test, I can just sketch myself out a little sketch to figure this out, right? Oh, I have a point at 1, 3. I have a point at 2, 6, 3, 9, and 4, 12. Well, that means this is going to pass the vertical line test if I just do a quick sketch myself with the information I'm given. The other way to figure out whether or not something's a function or not a function is we have to know the definition for a function. Does anybody remember what it is? Yeah, exactly. So every x value has only one y value. Every x value has only one y value. So if there's a point at 1, 3 and 1, 5, that x value of 1 has two different values of 5 and 7. So therefore, that would not be a function. So what you're really doing here is like analyzing your x values. If the x values repeat and they come to a different number, it's not going to be a function. Okay, so let's go down and look at kind of the ones that I have left here. So the first one is an arrow diagram. So you can kind of look at this two ways. If arrow diagrams are a little bit confusing for you, you could either take those, write them as ordered pairs, or you can just do a sketch. So if I'm using this definition, every x value has only one y value. That's going to make it a function. Otherwise, it's not a function, and it can have multiple x and y values. Do I have a whole bunch of different x values in this example? Did any of them repeat? No, none of them repeat. And every x value has a different y value. So it's good. This is going to be a function. If I'm unsure, sketch it out, right? This would be the point at 2, 4. There'd be a point at 3, 6, etc. What about this one, this arrow diagram? Here's x, here's y. Is that going to be a function or not a function? Function or not a function? So remember, every x value has only one y value. Do I have a repeating x value here? No, so I'm good. That's a function. Let me show you something that would not be a function for an arrow diagram. So if I had something like this, here's x, here's y. This is so -1, 2, and 4, and this is 0, 4, 6, and 8. Function or not a function? That would not be a function, right? Because right here, I have this x value that has one y value, and it has two y values. So right there, that would make that not a function. Okay, if you have multiple x values. All right, let's go look at the last two that are ordered. Oh, why'd you switch sides? The last two that are ordered pairs. So this example right here, we just went through, but really, if I just analyze my x values, so 1, 2, 3, and 4, those x values are all different, and we sketched it out before, so we know that passes the vertical line test. So that is a function. And take a second, is the last one here a function? 1, 0, 0, 1, -1, 0, and 0, -1. Function or not a function? Function or not a function? Not a function. Why? People who say it's not a function, where is it not a function? Yeah. 2 x values that are 0. Yeah, I have a point at 0, 1 and 0, -1. So it would fail the vertical line test at that point. So that is not a function. All right, next big thing is function notation. And so function notation is especially important in 20-1 and 30-1, a little bit more so than, you still need to know it for the -2 route, but a little bit more here. So rather than looking at equations in the form y equals 4x, we have this function notation, which then we can take and do transformations to, is kind of what function notation can be used for. And so a regular function like y equals 4x minus 6 is just going to become this f of x equals 4x minus 6. So the equation itself doesn't change. All that's changing is what it equals. So we change it from y equals to f of x equals, or g of x equals, or w of x equals. It doesn't really matter what that first letter is. And I just kind of gave some information there. So doesn't mean that f and x are multiplied together. It means that f is written in general terms of x. So if I had something like f of 3, we would be referring to the value of the function at 3. So really what this is saying is, when x is equal to 3, what does the rest of that equal to? So what is the y value at that point? Oh, I'm not going to have enough room here. Pardon? Just let me go through the examples. Okay. So if you remember function notation, I have two different forms that they give me. They might say, like, if you have f of 7, what's the corresponding y value? Or what's x when f of x is equal to 53? These are kind of the two different ways that I might be given this. So given two formulas, so they give me this first formula, f of x equals 8 minus 3, and g of x equals x squared plus 2. It says evaluate the following. So they're saying, what's f of 7? Now, the way that I usually look at this is, in this equation, what should be right here? X. What are they saying is there now instead of an x? 7. So really they're saying, like, if x is equal to 7, what is that formula now going to equal? So wherever there is an x in the formula, I'm now going to replace that with a 7. So this would be 8 times 7 minus 3. So 8 times 7 minus 3, 53. 8 times 7 is 56, isn't it? No, am I wrong? Okay. That's the first type of question, f of something. And then you have to essentially figure out the corresponding y value. So what this is telling me is it's saying that there's actually a point at 7, 53. That's all that function notation is doing. It's saying, here's the x value, what's the y? The other type of question is like C here. So they're saying, what is x when f of x is equal to 53? Now, they kind of already give me enough information for me to indicate what I'm looking for. They're saying, what is x when f of x is equal to 53? So that means in my formula, anywhere there was an f of x, I'm now going to substitute what? 53. So I'll put 53 in on that left side. So 53 is equal to 8x minus 3. And so now I have what I'm looking for because they're asking me what is the value of x. We have to remember, however, how do I solve for that x right there? Algebraically. So what's the first thing I need to do? Isolate the variable. So I'm going to isolate the variable. Remember using SAM/DEB. So get rid of subtraction and addition first, and then get rid of division and multiplication after that. So to get rid of this minus 3, I'd have to add 3. So I have, did I really use the same number? Oh my gosh, sorry, not mean to do that. 56 is equal to 8x, and divide that by 8 on either side. So x is equal to 7. I guess I could have just summarized that from before, but I didn't realize it was the same. So what that's saying is when I substitute 7 in for x, that corresponding f of x value is 53. Should I go through B and D over there looking at the g of x formula, or do you guys want to try that one? You guys will try it? Okay. So take a second and try B and D on your own then. Okay. All right. So first one is saying, what's g of -5? And so that's saying now wherever there is x, we're now going to replace that with a -5. So in that formula, so Lang, you're on the right track there. So -5 squared plus 2. So -5 squared is 25. Add 2 to that. That gives me 27. And I use the exact same number down here. Why did I do that? Oh, well. That's what happens when I try and make up a question. Anyways, let's still solve it as if we didn't know the answer. So it says, what is the x value when g of x is equal to 27? So if they're telling me g of x is equal to 27, 27 is going to go where in this formula? For the g of x. So I'll put it right here. So 27 equals x squared plus 2. And we still need to solve to figure out what that x value is. So I would subtract 2 from either side. So 25 is equal to x squared. And then square root that value. X is equal to plus or minus 5. So technically there's actually 2 answers for that one. Because remember, every time you square root a number, there's 2 possible answers, the positive and the negative answer. Okay. A little bit more difficult question here, more application of this function notation, but I'm just going to go through it because you might see it on the test. All right. So they give me 2 graphs, and just so we can maybe see this a little bit better, this is f of x. Oh my gosh, I'm sorry. My terrible. Okay. And here is g of x. G of x. So they're asking us 2 things. So what is f of -5? So once again, you have to remember, like, what are they saying here? So f of -5, that's really telling me what part is 5. Is 5 the x or is 5 the y? 5 is the x value. So x is equal to 5. So on this f of x graph, I'm going to go to 5, which is right here, on x, and just go find the corresponding y value, which is right here at 10. So really, you're just kind of giving the other point of that ordered pair. So that's at the point 5, 10. So take a second and, like, in your head maybe, see if you can figure out where g of -4 would be. Oops. G of -4. Anybody think they know what g of -4 is? Approximately? So you're going to go to -4 where? On the x. So I go -4 on the x, and then I'm going to find the corresponding y value, which is probably right at 1. Right? Yes. Okay. I probably don't need to do those, but we'll just see this. Okay. I'm going to add an extension here. Let's see. Let's see. What is f of -2 minus g of 0? F of -2 minus g of 0. Yep. Number A. Yep. My favorite number. Yours too. Mm-hmm. Mm-hmm. Well, because I want to see where it touches this actual graph, right? I can't just be like, oh, over here. I'm looking for if this x value is 5, on this line, what's the corresponding y value? Like, what's the coordinate? Well, that coordinate is at 5, 10. So I'm looking for that value. Okay. So f of -2. So I'm going to go to -2 on the x. So -2 on the x, and I'm going to this f function. So I'll go down all the way to here. So that corresponding y value, or f of -2 value, is what? Nobody knows the corresponding y value there? Be what? Yep, -5 minus g of 0. So I'm going to go to where on the x for g? 0. So 0 is right here. And I got to go find where that's at. That's so -5 minus -5. My answer would be -10. Kind of a hard, like, standard of excellence question dealing with function notation. Continue. So I'm hoping not to go through these two, and then that's okay. Continuous and discrete data. Is everybody okay for that? Not a ton, or if any questions on that, but still something you need to know going forward. Continuous versus discrete. What's continuous data? Right. This is like something you can break down. So on my graph, it's going to look like some continuous lines, right? And usually we're dealing with like time, money, things that you can break down into smaller and smaller sections. Discrete data is what? People, yeah. They would be individual data points that you can't or you don't connect on a graph. There's no, just because you're continuous, like, right, these are two different definitions. You can be continuous, nonlinear, and continuous and linear. It depends on the function. Linear versus nonlinear, I'm assuming, again, everybody could identify those pretty easily. Yeah. Linear is what? It's going to be a straight line, right? So this is linear. What's the degree of a linear function? Anybody? What's the degree on x? It's 0 or 1. Yeah. Nonlinear relations are going to be something that's not a straight line. Maybe it's curved. Maybe it's a zigzag. Nonlinear functions could look like this, or like this, or right like this. Those are all considered nonlinear functions. And if you want a little bit more information for discrete and continuous, linear, nonlinear, there's lots of information. I think there should be enough to kind of answer any other questions in that notepad, okay? So just read through that. All right, domain and range. So one of the big things you need to know moving on. So domain is talking about what values of your graph. All of the possible x values for a graph. And range is talking about all of the possible y values of a graph. And we have two different notations. We have set notation. And we have interval notation. And I don't want to spend a whole bunch of time reteaching that essentially. If you really need a whole bunch of additional information, there's lots. I think there's quite a bit of information that I put on here. Did I not? At least I felt like I did. Oh yeah, there is. So set notation, there's a whole bunch of information for set notation and a whole bunch of information for interval notation on there, and then some examples. I will go through some examples in just basic here. So interval notation, remember interval notation is the lowest possible number a graph can be, comma, the highest possible number a graph can be. And then on the outside here, we put some sort of bracket. And the bracket corresponds to whether or not you can equal that number. So I have two different types of brackets. I can use curved brackets or I use square brackets. Curved brackets are used when you cannot equal a number. So cannot equal a number. When you cannot equal a number. So that would be something like open dots or infinity. That's generally where you use those curved brackets. Square brackets are when you can equal a number. Can equal a number. And so you can usually equal a number if I have a closed dot, or if a graph kind of like touches or bounces off a point. Touches or bounces off a point. Okay, and we'll go look at set and interval notations for all these examples quickly here below. Interval that's interval notation. Set notation, you start off with your squiggly bracket, and then you got to go X or Y, depending on if you're talking about your domain or your range. And then we have this line that means such that. Then the next thing I would put is some sort of restriction if there's any. And so remember, a restriction is like if a graph can't go in both directions forever and ever and ever, there's going to be a restriction on the graph. Is it greater than 7? Is it between two numbers? Is it only a single number? Right, we're going to put that restriction there. And then comma X, E, R. Or sorry, I guess this should be X or Y, depending on what you're talking about. And we say ER to say it's an element of all real numbers, because most of the graphs that we looked at are for real numbers, which can be, any number within a given range. So that's just a really basic explanation of set and interval notation. Some more information for, especially for set notation, talking about the restrictions is in the note package, and I think it's pretty comprehensive in there. I'm just gonna erase this so I can do this first example. First example is a little tricky. Anybody know why? This first example right here, a tricky question. Anybody know why? It's discrete data. So what do I do if the data is discrete? Anybody know? I can't just say the numbers are all real numbers from -4 to 2. It doesn't work that way, because if I say all real numbers, that means I could be any number within this range, which is not what's happening with this graph. Yeah, Ashley? Right. If you have discrete data, all you're going to do is list it out. So for my x values would be at -2, 1, or sorry, -2, -1, 0, 1, and 2. So -2, -1, 0, 1, and 2. And then I say all my possible y values. And again, all I'm going to do is list them out. So there's a point at -4, -2, 0, 2, and 4. So just list those out. So that'll be something that a lot of people will get caught up on. They'll want to go, oh, it's between these two numbers. But if it's discrete, you can't say it's between numbers, because you can't be part of a number, where in all real numbers, you're saying that you can. All right. So I'm quickly going to do interval and set notation for both of these. So looking at this graph, we'll call this B. This is called a sinusoidal function. And so if this graph is continuing in this direction, sorry, I need to rephrase that. I just said it, so I might as well keep it there. Okay, so this graph, let's say that it continues this exact pattern forever in both directions, right? So the highest possible x value that I could be here is what? So the highest possible value is infinity, and the lowest possible value, negative infinity, because it's going to go down that way forever. So if I'm using set notation, the lowest number is negative infinity, the highest number is positive infinity, and I need to put a curved set of brackets around there because I can't equal infinity. What about the range? What's the lowest possible number on the range that I can be? The lowest possible number there. Can I go down forever? No. So what's the lowest numerical value here? 1. And the highest number? 3. So all that can happen for my range here is between those values. So the range, the lowest number we said, was 1, comma, the highest number is 3. Can I equal those numbers in this graph? Yeah, because we're going to assume that this graph, it comes and it bounces off 3, and then it comes back down, bounces off 1, and it keeps going. So we could put square brackets on there to indicate that I can equal that number. My other notation, set notation. So for the domain, well, we said domain can go both directions forever and ever and ever. So I start off with the curved bracket. I'm talking about domain, so it's x such that. So x such that, and then I put a restriction. Is there a restriction here? Nope, because I can go both directions forever, so it's just x, e, r, and then I close that bracket. Range for this one is a little bit more difficult. So if I'm doing the range here, so I start off with the range, so I'm saying y such that, and now I have a restriction. And so when I'm looking at the restriction here for the domain, or pardon me, the range, it's between two variables. And so if we have a restriction between two variables, what we do is we put y in the middle. Both arrows are going to point to the left. And I'll put the lower number over here, which is 1. Can I equal 1? Yeah, we said it touches that, so I'll put the equality sign under there. And then I'll put the higher number here, which is 3, and I can also equal that number. So comma, y, e, r, saying I can be every number in between 1 and 3, equaling 1 and 3. Should I do C, or how does everybody feel? Do I need to do C? Everybody's good? Feels okay with domain and range? Okay, there's some additional examples on there, even if you want to just go like cover them up, try them yourself later. Last thing I'll look at here, or I guess second last page here before we take a break, is looking at finding the X and Y intercepts. And so finding the X and Y intercepts is important, especially when we go look at the next unit, which is looking at equations of a line. So we can do this two ways. We can find the x-intercept and y-intercept graphically, or we can do it algebraically. It doesn't really matter. Depends on, I guess, if it's a written or multiple choice section. Algebraically sometimes can be a little bit quicker than graphically, because to find the x-intercept, what do I need to do? Anybody remember? To find the x-intercept algebraically, what should I do? Make the other variable, so make y equals 0. Because I'm saying, what is the point at which the x, or the graph, crosses the x-axis? Well, that's where y is equal to 0. So I'll make y equal to 0 and solve for x. If I'm doing my y-intercepts, well, the y-intercept, or where I cross the y-axis, is going to be where x is equal to 0. Yeah. Come and go, please, not me. Okay, so x is equal to 0. I make x equal to 0 and solve for y. The other thing that you can do is graphically. So if you're going to do this graphically, and again, if you want a little bit more detail on how to do this with your graphically, check the notes. So graphically, you need to be in y equals blah, 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 right? Because that's the only form that our calculators are going to understand, y equals. So if I don't have an equation like b in the form y equals, I need to get y by itself before I could solve graphically. To solve for the x-intercept, you're going to go calculate the zeros. You're going to calculate the zeros, and then it's like left bound, enter, right bound, enter, guess, enter, and it'll tell you the x-intercept in that range. And again, there is a little bit more information on what buttons to press on the review. Y-intercept, pretty easy. all you're going to do is you're going to hit the trace button, and you're going to trace, because when you're tracing along x values. So you'll just type in 0, and that'll give you right to your y-intercept. Sometimes you just start and it's already on your y-intercept. Just do one example. Is that okay? Quickly. It's zeros. No, literally the buttons, the thing that you have to scroll down to says zeros. Yeah. I don't even know if there's a 0 on that one. So, okay. So then to find the x and y intercept, I'll do that quickly here. Let's do this one, I guess. So to find the x-intercept here, so the x-intercept, I make y 0. So 0 equals negative 2x plus 14. And then to solve for the x-intercept, I would add 2x, add 2x. You could minus 14 too, it doesn't matter. So 2x is equal to 14. And then I would divide that by 2. So x is equal to 7, which means there's an x-intercept at 7, 0. Okay, and I could do the same thing for my y-intercept. This one's already set up. If you know y equals mx plus b, well, the b value here is 14. But let's still go figure this out. Y-intercept, make x equals 0. So y is equal to negative 2 times 0 plus 14. So that's just gone, right? Negative 2 times 0, so y is equal to 14. That's the coordinate of 0, 14. And I feel like most people were okay with solving for the x and y intercept. Okay, last one that I'll take a look at for break here is the slope. So slope is also called the rate of change. You kind of have to be able to do two things. You need to be able to figure out the slope given a graph, given points, and also you need to be able to like interpret and say like what the slope means in the context of the question. So if you are given this, m is equal to rise over run, or m is equal to y2 minus y2 minus y1 over x2 minus x1. You are given that information. So if you're unsure of the formula, please make sure you refer back just so you don't mess that up. All right, so let's take a look at this question. So it says determine the rate of change below, so given this information, and what it represents. So it says this is the cost of running a backhoe. So this is the cost, and this is the time. So what does this slope represent? I'm comparing what two things here? Oops. I'm comparing what two things? Dollars and hours. So what am I, in the context of this question, when I divide those two numbers, what is it going to give me? Dollars per hour, which is talking about what? Right, this is the cost per hour to operate that backhoe. Now, if I need to find the slope, I can do this two ways. I could do the rise. So the rise here is how much? What's the rise of that question? Is it 4? Yeah, no, maybe. Let's see if I can zoom this in. Okay. Anybody? So the rise is how much? 400, right? Make sure you're looking at the scale of the question. Just because it's 4 tick marks doesn't mean that it's equivalent to 4. So m is equal to the rise of 400 over the run of how much? Over the rise of, yeah, each tick mark here is actually worth, so over 5, whatever that gives me, 80. So the slope here would be like $80 an hour. Given 2 points, does everybody feel okay? Given 2 points, they can substitute those in. I don't need to go through that. Everybody's good? Okay, just make sure that you are, like the big thing would be people when they substitute this in, right? So y equals, so x1, y1, x2, y2. 3 minus 7 over 13 minus a negative 3. Bring your sign with you. A lot of people mess that up. And if you don't bring that negative, you can guarantee the other answer is going to be on there. So you're going to be like, hey, I did it right. But really, you forgot your negative. Whew, okay.